Hello, my lovelies. It's Susanna, and today I want to show you how to solve this problem. Find the area of the inscribed rectangle. Okay, we have this rectangle here inside of this triangle. The edge of the rectangle is on this side here, and both sides of the rectangle are on the sides of the triangle. We get the length of this part here and this part here, and we need to find the area of this rectangle. So I call this area A, and we can find it by taking the length of one side of this rectangle, I call it X, and the length of the other side of this rectangle, I call it Y, and then just take the product, so X times Y, to find the area. Okay, how can we find X and Y then? If we take a look at our triangle, we see that from the angles, we have a right angle here because of this rectangle. So it gives us a right angle here, here, and here as well. Which means that our big triangle here is a right triangle, which makes calculations usually easier for us. But we also have a right angle automatically here then, and here as well, which means that these smaller white triangles, this one and this one, they are also right triangles. And we get more information about these smaller triangles, right? We get the length of this side here and the length of this side here. So maybe we take a closer look at these two smaller white triangles. What else do we know about them? Well, the length of this side here is just my X. So my X is part of this small triangle here as well. And the length of this side here is my Y. So Y is part of this as well. And if I compare these two white triangles, they look pretty similar to each other, right? And maybe they don't just look similar, but maybe they also are similar in a mathematical sense, which would be great because then calculations are even easier for us. So how can we say that two triangles are similar to each other? We can compare the angles. If they have the same angles, all three of them, then they are similar to each other. So we already have the right angle. Okay, check. What about this angle here? I call it alpha. Can I find alpha in here again? It looks like that this could be alpha, but what would be the explanation for this? The rectangle, actually, because this side here is parallel to this side here. So if I just draw a line like this here through the rectangle, and also here I draw a line through the rectangle, then these two lines are parallel to each other. So if I draw it here, I have these two parallel lines, and then they are crossed by this line here. So this line here, I have my angle alpha here, and then I know that this here is a corresponding angle to this one, and it has to have the same size, so I have alpha here again. So this is really alpha. And with this, the third angle has to have the same size as well. So if I call it beta, I automatically have beta in here as well. So my triangles are similar. On the next page, I drew these small white triangles again with all our measurements we have found so far. So it looks like this. And now I want to use the fact that these triangles are similar by comparing ratios of corresponding sides. So which are the corresponding sides? When I start here from alpha and go to my right angle, this side corresponds to the side where I go from alpha to my right angle. This means if I form the ratio, so 11 over x, this is equal to, if I take two different corresponding sides, so from my right angle to beta, and from my right angle to beta, and if I form the ratio now, so y over 5, and this is an equation, and I have my x and my y in here, and maybe let's rearrange this equation a little bit so maybe we can see something there. Maybe first of all, we get rid of this fraction here, so we multiply both sides by the 5. So we multiply by 5, and we multiply by 5 here as well. So we have 55 over x on the left side, and these two cancel out, and we only have our y here. Then maybe take the x to the other side by multiplying by x here as well, both sides. This cancels out and only our 55 is left. And here we have y times x, or x times y if you want to rearrange this. X times y equals 55. Do you remember from the beginning what we were searching for? We wanted to find the area of the rectangle, right? So we now have that x times y equals 55. So let's get back to the beginning. X times y was what we were looking for, and we just found out that it is 55. So we found the area of our rectangle, and we solved this problem. I hope you enjoyed it. I'm curious how you solved this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!